Shall we start?
Yes, sure. Let me just share my screen with you.
Yeah, let me introduce yourself.
Sure.
Yeah, ma'am, let me introduce you. Then you can.
Okay, sure.
Yeah. Very good morning, ladies and gentlemen, distinguished guests, delegates, and participants. A very good morning once again. So I'm Mr. Prakash, working as Assistant Professor in the Department of Computer Science and Engineering in the NERIST of Engineering and Technology, Andhra Pradesh, Visakhapatnam. So I stand here before you today with a great honor and privilege as we gather here for the second keynote session 2 in third International Conference in Machine Learning and Big Data Analytics ICMLBDA 2023 is jointly organized by National Institute of Technology and Northeastern Regional Institute of Science and Technology, Arunachal, Pradesh, India. So on behalf of the organizing committee, it's my utmost pleasure to extend a warm welcome to each and everyone one of you. So we have an eminent person, Dr. Ligaa Nawaf, is going to deliver expert talk on optimizing infrastructure, placement, and cybersecurity architecture using AI. So I deem it a pleasure to introduce the profile of Dr. Ligaa Nawaf. Dr. Ligaa Nawaf is working as a senior lecturer in cybersecurity with the School of Technology's Program Director for Postgraduate Studies at Cardiff Metropolitan University and a co-leader of Cybersecurity Information Network Center, CANC. Dr. Nawaf is an expert in networks, artificial intelligence, and cybersecurity. She is particularly interested in understanding how artificial intelligence techniques could be used to support in distributed systems and the use of these techniques in various application areas. So Dr. Nawaf is the founding member of Women in Cyber Wi-Fi Society at CMU. Dr. Nawaf is an active member of Women in Cyber Cluster in UK. As one of the only women member of CMU staff working in the discipline of cybersecurity, Dr. Nawaf has been successfully securing a number of externally funded projects exploring different aspects of cybersecurity, as well as securing competitive CMU internal funding from the global academics, research and innovation development. She's a strong female mentor in her department, advising on research projects and identity projects relating to information technology and cybersecurity as program director for the Master of Science degree. Dr. Nawaf supervises a number of PhD students in the area of artificial intelligence, networks, and cybersecurity. So we have an eminent keynote speaker, Dr. Ligaa Nawaf. We're eagerly waiting for your talk, ma'am. Over to you, ma'am.
Thank you so much, Pete. Thank you for the introduction. I'm grateful for this invite, and I think you almost introduced me, and I have nothing to say apart of just saying good morning, everyone, or good afternoon back there. I'm not sure what is the time right now where you are located. So I just want to share my screen. I'm not sure if you can see my presentation.
Yes, ma'am.
You can see that. Okay, thank you. Okay, once again, hello everyone. So today our talk will be more involved in artificial intelligence and cybersecurity. So as Pete introduced me, I'm a senior lecturer in this field. So the topic is optimizing infrastructure placement and cybersecurity. So the outline of this talk today, we will look into the research and innovation. Then I will go through implementing artificial intelligence to optimize infrastructure placement in wireless mesh network. And then we'll move on to approaches in wireless mesh network, followed by the cybersecurity architecture in AI. So just to say that my research journey has started with optimization of infrastructure placement, and then I moved on, or let's say carry on with that by looking into the cybersecurity impact of this architecture field. So coming to the optimization of the infrastructure placement, so the project aim and the objectives of it started by designing and implementing algorithms. So we looked into different types of algorithms for improving and performance of efficiency of wireless mesh network. So I considered investigating the trade-off between the different performance objectives and develop an algorithm that makes use of this trade-off. We considered objectives, so we'll come to that. But first, I would like you to see that picture. So as you can see here, we have a city which is involved in building houses. You can see there's trees and so on. So my main objectives, I would say, or my main goal here was to consider the performance and efficiency of wireless network. How to make all these people or users are happy with their bandwidth. At the same time, we need to consider the cost. So as you can see here on that picture, so we can see there is a gateway, or we can call it access point, whatever you like, on top of each building. So that gateway will receive the, let's say, the bandwidth or the needs from these houses. On top of each house, there is a router. So the routers are connected with the access point or gateways, plus it's communicating with the neighbor node or neighborhood. So because it's a wireless mesh network topology. So from here, we consider the far and near nodes in relation with the ITAPs, or we can call it again gateways. In terms of the area that's connected to. So as we can see, let's take an example here. You can see that gateway. We have one here and another gateway here and another one. So that means the near nodes would communicate to the nearest gateway, okay, and so on. So that's to consider the communication, the efficiency, and at the same time, we don't want to deploy many access points in terms of the cost of them. So I'll move on to we need to understand, for those who doesn't understand, what is wireless mesh networks. So it's a network topology. So it can be that we can say is any wireless network having network topology of either partial network or full mesh topology. And it consists of mesh client and mesh router. So as I said, is a network topology that each node will transmit data from one network to another, as you've seen in the previous image here. For instance, that node can transmit the data to that node, and then that node can transmit it to that node, and then they can communicate, or they send, or that node would send the data to the gateway. Okay, so as we said, these the point of wireless mesh network is to be in the neighborhood or transmit the data in that communication area. So all mesh nodes cooperate in distribution of the data, so they help each others. In wireless mesh network, we can say a mesh router is deployed at each house, as you've seen in the image. So that's the point of it, to act as a local access point. So then it can pass to the nearest house the data, or could pass it to the nearest access point. What do we mean by access point? Or we call it internet transit access point, or we can call it gateway. So this is the node that it acts as an entrance to another network, or we can call it is the acting or serving the internet from the provider. So the project aim is to design a wireless mesh network that aims to minimize. Okay, now we consider the three objectives. So what are we considering here in that project? We're considering to minimize the number of access points that's required for that a grid area, or let's say for that city or that data, plus maximizing the traffic. So we need at the same time to satisfy all the users with the traffic. So that could be served to each house. So each house, they will have a network, and we need to satisfy this house or that user. So we call this a multi-objective optimization algorithm here, that is to investigate and to solve the wireless mesh network infrastructure placement problem. So in other words, our objectives is here to minimize the number of ITAPs in terms of the cost. We need to minimize the cost, and instead of having access point to each single house, which is going to be a very costly for any service provider or any network, plus maximizing the traffic, and to be fair. So to be fair in terms of giving a fairness that each house will get their demand. The project overview. So what we did here, we had a data set. So let's say we have a set of access points, set of houses, or we can call them nodes, that's being deployed on the grid area. Grid area, we started from small grid area. We're talking about 50 meters by 50 meters XY. And then we moved on to 1,000 plus 1,000 by 1,000 in terms of the grid area. So we started with a small area, talking about 5 ITAPs, number of houses, 10 houses, 20 houses, and then we expand this data. So here it's very important we consider the ITAP placement problem, because this is the main objective. Where do you put or where do you deploy your ITAP, your access point? So that would solve the efficiency manner by using novel move operator. We consider different move operators. We'll talk about the move operators. So the experiment has showed us a good evaluation efficiency in terms of the combination of all 4 move operators. We started with move operators, different move operators. So I just would like to consider this. Okay, so coming here in terms of the nodes. So as I said, we had a grid area, small grid area. Let's start with that experiment. We had number of houses. Each house would, or let's say each node would have an in and out. We call it in and out. This is as a virtual node of the house, let's say. And the idea of it to consider the capacity of the link of the house. Same thing would go for the ITAPs. We considered ITAP in and out node, and this is a virtual node, so that we can allocate the capacity for that node. Coming here to that small space here, you can see there is a nodes here communicated. We have houses. You can see the in and out. As I said, we expected to have a capacity of that link. Okay, for each house, we would have the capacity for the ITAP as well. So the idea of having sink and source, Okay, so the source would send the request, or let's say would send the data, okay, from, and then the sync would receive. So the idea is to set link capacity of these edges to infinity. So by we applied here the flow algorithm, so we can consider it. So you may ask why we have the oval. As you can see here, that oval. So that indicate these two houses are in the communication range. So for each experiment, we would have a communication range. So that means if these two nodes are within the communication range, that means they can transmit data to each others. So in other words, that we can see which ITAP is the nearest to these two nodes. It would be that one. So that means this node is too far compared to this. So what's happening here? The data would be sent to the second node, and then that second node, because it's the nearest to the ITAP, would send the data of the two nodes. So that indicate these two nodes are in the communication range, that they can assist each others in terms of transmitting the data. Same thing here. So that again, that node would send its data or request to that data to that node, and then it will be sent to that ITAP. You can see there are some nodes outside the communication range. So these nodes would communicate direct with the ITAPs, and then the ITAP would send it to the sync. So that's where we say it's the internet communication. Coming to the move operator. So I did say we used a four move operator. So what I mean by move operator? So here we considered the site of Y represent is the each Y means that this is a site of ITAPs. So how many ITAPs do I have? So as you've seen in the previous image of the city, so we have number of ITAPs, and these ITAPs are connected. So each site would have a number of ITAPs or gateways. So as you can see, I have here for that experiment, I have 5 sites, and each site would have number of ITAPs. So for example, site 1 would have 2 ITAPs, site 2 would have 3, and so on. Site 4 has nothing, 0, because we considered that 0 because there were no houses allocated around the ITAPs. So in terms of the swap, so what do I mean by swap? So I considered swapping the number of ITAPs. So instead of Y2 has 3 ITAPs, now it will have 1 ITAP. So what happens, they swapped Y1 and Y3, they swapped the number of ITAPs because we considered there were more requests at that site, allocated many houses needed more requests of data. So we swapped the number of ITAPs. In terms of the reallocate, it acts differently. So again, instead of swapping the whole number of ITAPs or access points, what we did, we reallocate. So we increased, or we gave one of the ITAPs allocated in site 2 to the third site. So instead of having here 3, 1, we would have 2 and 2. Okay, so that's in terms of the swap, move operator, reallocate, move order. And then we had add and delete. So with the add is just by implying increment. So like, for example, at site Y, if we suggested that would have a 0, no ITAPs, and then we consider there was a demand, so we will add one ITAP here extra. So we will not play with these number of ITAPs in these sites. So that's in terms of add. In terms of the delete, we will decrease the number of ITAPs in any of the site if it's requested. So again, we come into the move operator. So that considered combining all these move operators, so we can consider a good, efficient network. So moving to the approaches. So at that project, I looked into two approaches that they've been compared to investigate multi-objective optimization. So we considered the first approach is the weighted sum approach, so that we looked into normalization of these, normalizing the weight of each node. So we looking into the number of ITAPs, we looked into the demand of each of the bandwidth or of these houses, and so on. So the weighted sum is a different approach, or let's say it's a simple approach that's being considered to sum the weight. So the three objectives will be weighted, will be giving a weight, and then it will be normalized to a single objective. So that was the weighted sum. And then we considered the evolutionary algorithm using the crossover and mutation operators. With the evolutionary algorithm, we considered the non-dominated genetics algorithm. And with the weighted sum approaches, we considered heuristic and meta-heuristic algorithm again. We used, or let's say we implemented greedy algorithm, hill climbing algorithm, simulated annealing, and so on. So the idea, again, it's based on a simulation analysis that it's used to demonstrate the benefit proposed for these two approaches. So we provided a flexible and low-cost technology. So when I say low cost here, so that means I was successful in minimizing the number of ITAPs, plus giving a good bandwidth to the neighborhood node, or to the nodes in that area. That will deliver a broadband service to communities. And then effective ITAPs deployment. We deployed, let's say, these ITAPs in a good location. So that means all these nodes will be, these nodes who were requesting a bandwidth were satisfied, and they were obtaining a good internet service. So the experiment has showed that the move operator helped improve these three objectives, because we considered the 4 move operators, plus we considered also aggressive move operator. So with the aggressive move operator, that was used to the houses, because as you know, we can move, or we can play with the placement of the ITAPs. I can place the ITAP anywhere in different building, different location, but it's not possible to change the house. It's, in other words, it's not possible to move the house from one location to another. So we need to consider the reality, not just let's say to consider real link model, not just a simulation model. With the simulation, I can move around. And then I come up with the aggressive move. So with the aggressive move, now you might think, what do I mean by aggressive move? So with the aggressive move operator here, considering that allocating the bandwidth to each house. For example, if the house A and house B, if house A requests a higher allocation, I would consider a high or let's say aggressive move in terms of allocating more bandwidth to that house. So we'll look into the next slides. We'll explain this in more detail. So the aggressive move showed a significant effect in terms on data set that we had used. And then from the experiment, we looked into as I said, we used the genetics algorithm, a meter heuristic algorithm. So with the non-dominated genetics algorithm, we considered different crossover. We considered arithmetic, hybrid, we considered intrusion, arithmetic and hybrid. And then we come up with that the hybrid crossover and the Gaussian mutation operators has given a better better result performs the uniform and the hybrid crossover that we considered. Looking into the allocation move operator. So as I said here, as you can see here in that slide, I considered allocating 0.1 of bandwidth, 0.3, 0.5, 9, and 1. So the highest allocation would be 1, and the lowest would be 0. And each you can see on that grid area. So on that grid area, I started with the number of items from 0 to 110. And then in terms of the number of houses, we have from 0 till 1,000 houses. So you can see here that regarding the number of houses, you can see the slope. So when we have here, that's mean the unserved houses, yes? So if we have higher number of items, so like here we have 50 number of items, that's mean we have 0. 0 houses are unserved. So in other words, all the houses, all the request demand is being satisfied. So that means we have 0 unserved demand. So everyone is happy with the 50 items. So that's when we give allocation of 1. So I give to the houses with a high allocation, provide them whatever they request. So that means with 50 houses, we have everything is fine. So coming up with the 0.9, you can see the slope here. When I use that allocation, that would give me with the 50 houses, 100 houses unserved, so are unsatisfied. So you can see the slope here. So in other words, if I increase the allocation of the demand for these houses, so that means I would have 0 unserved demand. So everybody would be, all the requests would be satisfied. So it would be everything will be working. So what I implemented here, I looked into simulated annealing algorithm. With the simulated annealing algorithm, it's a sophisticated algorithm. Let's say it's a meter heuristic algorithm. It can give good result, but it can take a longer time if I implement hill climbing. So again, combining the move operators, the 4 move operators, just to remind you of the swap, reallocate, add, delete, plus the aggressive move operator. We called it aggressive move operator for the allocating the houses. Okay. So as you can see here, what we did, we spread of solution is efficient and to find out a good solution. So I spread the allocation from 0.1 to 1 to show a good solution. Looking into non-dominated set of all solution are provided for comparison. So what we can see here, it's a different initial solution of the bandwidth allocation. So you've seen on that grid area, it's been spread everywhere on that grid area to show that was applied to all houses. So the result here you can see, as I said, that's why I use simulated annealing algorithm. From that table, you can see that's the number of experiments. Let's say I had different experiments, and these experiments would have different parameters, weight. We looked into the capacity of these nodes. We looked into the number of ITAPs, how many ITAPs I've been deploying or allocating to that grid area, the grid area size. We looked into the wireless communication range. So are they in the one range or different ranges? So again, just to remind you, in terms of the wireless communication range, if the nodes are into the communication range, let's say the grid area is 500 by 500, and the communication range would be 100. So that means that any node within the communication range around the 100 piece group of nodes would be communicating with each other. So looking into different parameters being involved in these experiments. Here we looked in terms of the running time for the cost min and satisfied houses, how many houses being satisfied, and what were the number of ITAPs for each experiment. So let's look at experiment 4.2. So you can see that experiment took a very long time, 1,555 seconds, right? So compared to the simulated annealing, it's not very long because it's almost half of the running time with the simulated annealing. But considering the cost, you can see here the cost is 735 and the cost here was 425. And then we looked into the satisfied houses. We satisfied the same number of houses, but the difference here is the number of ITAPs. I use 58 ITAPs, so that means the cost would be very high. So that's why we say the cost here, 735, because I used a number of ITAPs 58. That was the minimum we start with, and then we start with 60 and we end with the 58. You can see here with the simulated annealing, we satisfied all number of houses or the request, satisfied 495 houses, okay, with 27 ITAPs. So almost half number of the ITAPs or even less than half, and so on. So that the result showed us that we compared between these two algorithms in terms of efficiency of the bandwidth. Do you have any questions or shall I move on? Any questions? Or let's move on to the second part. So that I finished the first part in terms of optimizing the infrastructure of wireless mesh network. Here, as I said, my journey started, I said earlier, started with the optimization, and then we come up with the cybersecurity. So we considered we need to look into the security of this infrastructure or this wireless. So the key influence here in cybersecurity is the human behavior, emerging new technologies, laws, and regulation. We'll go through these three key influence of cybersecurity. So first thing you need to understand that the human as an end user and the hackers are both human in terms of offense and defense. So they both are acting here or have, let's say, have a tremendous problem to cybersecurity. So considering the human behavior, or let's say the human has showed the highest impact on cybersecurity. So looking into the human behavior, we all human, we all go through stress, especially when we have a lot of work, we doing a lot of you as a student or researchers, you will face a lot of let's say phishing attacks, data breaches, and so on. So the human behavior is very important in terms of the cybersecurity. A lot of humans don't have awareness of privacy and security. If they don't have any awareness, so that will give big impact on the any act or behavior of the human. So let's say any human without knowledge, without the skills, will cause a big effect on the system, on the network, data, and so on. So human need to understand also the threat of a criminal attack. So considering all this in terms of any employee, any now, you can see the SMEs or any organization, they consider now the first step in terms of the security is to give more training, more courses to their employees to be up to date. So they need to understand how the hackers think. We need to be ethical hacker, let's say, or white hat hacker, because the hackers will always try to use the vulnerability of the system. We can see that by the high rise in the malware and phishing, data breaches, social media hacking, web server mistakes. So all this will go under the hackers. So in terms of the cybersecurity, we have been identifying a lot of cybersecurity threat we've seen. So that's why we say it's very crucial and significant in determining the sustained security mechanism and approaches. So in other words, it's very important to consider the security of your network, of your architecture, to avoid any threats, to avoid any attack, data breaches, and so on. Especially with the wireless mesh network, we considering here the poor infrastructure. That's why we considered the wireless mesh network. So considering the cybersecurity or cyberspace challenges and threats in disruptive array with significant approaches, the idea is to mitigate or to minimize the risk of the cyber threats. How can we deal with this? It's a big challenge, how to consider or how to minimize the security now. We all can see what happens during the COVID or the pandemic, that we've seen a lot of attacks, data breaches, high risk threats to all of us in terms of as an organization or as an individual using your personal devices. So we considered the meta-heuristic algorithm. As we use the meta-heuristic algorithm in the first part of my research, and it showed a good and significant result in terms of optimizing the bandwidth, optimizing let's say the network. So then we start looking or considering this meta-heuristic algorithm into cybersecurity. So looking into this, is meta-heuristic algorithms are assimilated by a human brain, such as the genetics algorithm, SWAM algorithms. So there are so many algorithms that are coming from nature. So they imitate or mimic the nature. So what we used in that project is the meta-heuristic, which is involved the human brain, like genetics algorithm. So it will implement the AI and that will assist the neural network to mimic the behavior of a human brain. And the idea is to predict a significant outcome, or to predict a better result, a better solution, to optimize the request of the project. So we looked into enhancing the cyber security, or let's say the security of wireless mesh networks, by determining best placement of IoT nodes. So we considered different nodes here, IoT nodes, and to prevent the common attack that using AI and machine learning techniques. So the aim of the project is to study and to provide solution in the field of wireless network by applying meta-heuristic algorithm to detect the foreign node. So any foreign node will be detected during the experiment. Objectives is to design and implement algorithm. So we developed algorithm and we implemented this algorithm to improve the performance of efficiency of wireless mesh network by exploring different machine learning algorithms, as we did in the first part of the project, to determine the best placement. We looked into determining the first part in best placement for the ITAPs, and also we considered the 4-move operators by implementing this. Now we considered again the best placement of the physical node within the network to prevent any common security attack. So any foreign attack will be detected by this project. So what we had here is a range of wireless mesh network scenarios and in environmental environments will be run. So from real life, let's say scenario, will include the black hole and wormhole attack scenarios. I'm sure you all understand this. So to detect insecure nodes. So in other words, any node we think it's insecure, or that's it will cause an attack to the network or to the field, so it will be neglected. So the packet data will be recorded using a software for these nodes. Then we looked into search for a physical distance between each node. So as we said, the grid area, and propose a model that would allow for a stable network signal to maintain, but also help minimize the risk of foreign nodes. So in terms of the model, in the first in the first part of the project, we considered the ideal link model. So with the ideal link model, we neglected any interference. We didn't consider any interference because we were focusing on the cost of the ITAPs. We were considering the performance and efficiency. Here, with the security, we considered different model. We considered a real-life model, or let's say general model. So like we will consider any interference comes from the foreign attack. So that would minimize, so by changing the model to different models, so that means we will be considering any foreign node to minimize the risk of these foreign nodes interfering with the network. So the project contribution is to of this research is to minimize the risk of foreign nodes interfering with the network and optimizing the best placement of the physical node allocation within the network for better performance. We considered the intrusion detection system. We considered the intrusion prevention system, and that was used to record, as we said here, to record using these softwares or packet data, by using this bucket data of these tools on software to consider any foreign nodes. Then to maintain the quality of service. So by maintaining quality of service and handle a cyber threat by defending the network and defense the mechanism, let's say, or the mechanism that's being used in the project. Again, looking into the intrusion detection system software and intrusion prevention software. So that's in terms of the project, in terms of the cybersecurity. And then and the idea is, by the way, if you ask which language I've used here for this data, I've used the Python language script, and also I was involving mathematical equations here for the two projects by generating the small and big data set with different parameters. So that's in terms of the two projects that we considered. Here is the best paper being allocated. It's been given for optimizing infrastructure placement in wireless mesh network for the IEEE conference. And we come to the end. Thank you. Do you have any question? So these are my details if you like to contact me or you like to come back to me if you have any queries or question regarding the project. Thank you.
Thank you, Madam.
I'm ready for any question if you like.
Shall we wind up the session, ma'am?
Sorry?
Any queries from participants?
Well,
shall we end up this session?
That's good indication if there is no question, or could be bad indication. Okay, so that means I hope you liked my my project, let's say my talk, and you are interested in this research. So please, if you don't have any question, don't hesitate to come back to me. You have my email here, and my contact can go through the through Google Scholar to find all my publications here, and LinkedIn, ResearchGate, tweet, anything you like. More than happy to assist you. Okay.
Yeah, ma'am, just a moment. I would like to propose a formal vote of thanks. I would like to express our sincere gratitude for the enlightening talk you delivered on optimizing infrastructure, placement, and cybersecurity architecture using AI at this conference. So your presentation was truly remarkable and left a lasting impression on all of us in attendance, ma'am. Your deep knowledge and expertise in the field of AI and infrastructure optimization were evident throughout your talk. So the way you seamlessly integrated the concepts of infrastructure placements and cybersecurity was both insightful and thought-provoking. I particularly appreciate how you demonstrate the applications of AI and optimizing infrastructure placement and enhancing subject architecture. Moreover, your passion and enthusiasm for the subject matter contagious. It was evident that you genuinely care about advancing the field of creating a secure and evident digital landscape. I would like also acknowledge the seamless flow of your presentation, which kept the audience engaged from starting to finish. So your ability to captivate and hold our attention throughout the talk was truly impressive. The inclusion of visuals and the real-world example further enhanced our understanding and made the subject more relatable. Once again, thank you for sharing your knowledge and expertise with us. Your talk has provided us with the valuable insights and has sparked a further interest in the field of AI-driven infrastructure optimization and cybersecurity architecture. So we're truly grateful for your contribution And we hope to have the opportunity to learn from you again in the future, ma'am. Thank you once again.
Thank you for your invites, and I'm more than happy to assist all our students and colleagues. And it was a good conference, and wish you all the best for all of you here. Thank you so much. Thank you.
Thank you, ma'am.
Thank you.
Yeah, participants, I will share the feedback link to you shortly, and you can join again the third session again on according to the schedule given you. Thanks for being active participation. You can leave now and you can join the third session again at I think 2:30. Thank you.